So, Evgenia and Julia, so this topic also close to me, risk assessment and decision making of UAS operation counting wind and weather hazard. Go ahead, floor
Yes,
is yours.
hello. It's nice to meet you, and it is my pleasure. And moment, please. I upload the presentation. I'm Yulia Viryanova, and this paper developed by the team from the National Aviation University, devoted to the topic connected with different operations of unmanned aircraft systems and the tasks to identify, to assess the different risks to operations and flights to unmanned aircraft systems, and make approach to develop the decision making on the base of developed approach. Maybe not developed, but a little bit improved, because in research, our research is based on the some proposed approach that we have analyzed and have made some improvements. So, firstly, we just briefly about our motivation, some objectives of the research. Then we present the modified model for calculation of an important, as it is indicated, parameter to evaluate the ground risks for unmanned aircraft operations. Then short, brief results analysis, and proposed algorithm and decision making using the proposed improvements. First of all, I would like to mention that nowadays unmanned aircraft system becomes more and more popular and are proposed to use in different fields of people activity. Moreover, the emerging technologies, including the developments in air navigation, communication, different sensors, development of artificial intelligence, cognitive systems, these are opens possibility to use them at relatively high level, and allow to introduce the automation in the process of different operations. Moreover, it is also connected with the range some challenges connected with unmanned aircraft systems. And here it is indicated that challenges connected with so-called human-machine interactions, because nowadays unmanned aircraft system can be identified as the cyber, physical, and human system, because it involves all the mentioned components. So the some risks are also should be taken account, not only for the physical body of unmanned aircraft, but also for each of the component of the systems, like including the cyber component, including the human component. And these challenges are connected with such questions like privacy legislation, some human-related tasks. Also, we can see that vulnerability can be connected with transfer information in order to make exchange and continue operation performance, some technical issues, some cyber threats. And of course, as it is indicated also in some reports, and here the report of accident that was prepared by the Ministry of the Infrastructure of Transport and Tourism of Japan, that up to 2019, the high dynamics and change in weather conditions were the main reasons for drone accidents. So this was also our motivation to consider the weather-related hazards and take them into account when risk assessment for operations, unmanned aircraft systems operations. And of course, it is obvious that for effective decision making and successful operation, it is crucially to understand, properly evaluate vulnerabilities, threats, and possible risks connected with them. There are different approaches for risk assessment proposed in aviation, but European Safety Agency was proposed such approach that is called specific operational risk assessment approach, especially for operations of unmanned aircraft systems. That is based on the 10 steps, and it is possible to familiarize in more detail with this approach. And the key moment is to evaluate so-called the ground risk and air risk. So the ground risk is considered as the probability of some harmful event to facilities or people or any property that can be done by unmanned aircraft. At the same time, there were approach that allow to evaluate this ground risk, and one of the approach is based on so-called critical area calculations. At the same time, it is possible to find in the document of European Safety Agency that this critical area, it is a key element to determine the ground risk using this approach. And it is quite complex problem because of the range and extent of different contributing factors into the critical area calculations. The model that was proposed for calculation is also can be found in the indicated web page and the guidelines for the assessment of critical area that is indicated in this slide and is possible to find in the reference to our presented paper. And the calculation is based on the dimensions of the unmanned aircraft, the kinetic energy, the cruise speed of the unmanned aircraft, as well as the area over which the operations are made and density of populations. But there is no influence of weather phenomena. Analysis of the range of the paper connected with this approach also mentioned that after the research, it was proposed to make some modifications for different operations because it is rather maybe not too good to implement this approach for all the operations because it doesn't take into account all the possible risks. So again, it was our motivation to reconsider it and try to imply the impact of weather. And in this paper, we focused on the weather-related hazards and possible risks that can be connected with such wind-related hazards. So we proposed to slightly modify the model for critical area calculation in order to take into account the wind influence. And here in this slide, it is possible to see that the critical area calculations are done for different sizes of the unmanned aircrafts. And also we propose to take the wind into account into the calculation of the speed of the unmanned aircraft and make some corrections for each type of the sizes of the unmanned aircraft. The results of simulation according our improved model is shown here in this slide, and it is possible to see these blue lines. For three cases. Blue lines indicates calculation according to the previously proposed model, like it is proposed by the Yarus model and Aerospace Safety Agency. But also here we can see the wind consideration and wind of different wind speed and directions. So it is obvious that the larger, so the smaller aircraft, the smaller such deviation, and how it can be influenced by the wind, the unmanned aircraft of different sizes. So we can see the deviation from the mean quite high, quite big. At the same time, the critical area can be even smaller. It depends on the wind direction and particular wind field in the considered area. But it is obvious and clearly seen the significant impact of the wind when calculation of critical area that in turn is used to evaluate the ground risks. And again, some block diagram of improved algorithm for specific operations risk assessment. And it is possible to see that some initial data like type of operations, some parameters of a flight, some parameters of area should be taken into account firstly to denote the flight into standard scenarios, predefined risk assessment that is a little bit easier and doesn't require the risk assessment according to the modern rules, and those that are required the risk assessment to be done and to be sent for approval of the flight. Anyway, we introduce the general weather limitations for any scenarios because also we propose to take into account not only the characteristics of aircraft but the possible missions performed by the unmanned aircraft, because limitations can be connected with specific sensors that are used to realize particular missions, not only restrictions of the aircraft with some characteristics. So it is a crucial addition to identify it from the point of view of the mission. And also in the algorithm that follow the SORA approach to consider firstly weather limitations and taking into account the current weather conditions, current wind field to calculate or to make, it's better to say, to make ground risk assessment by calculating the critical area using the modified formula. And then to take decision using this information about the weather conditions. So some part concerning the decision making. Again, the idea is the mandatory evaluating not only the restrictions for particular aircraft, but for particular missions, evaluating the weather limitations, that the calculation of ground risks and taking decision at this level, and continuing with evaluating the air risk in the required area, and then final decision making. So this the main idea and main improvements to the existing model, existing approach. And just to conclude my presentation, I again wanted to mention that the improvements was made that allowed to take into account additionally to the proposed in the existing model the wind-related factors to take it into account. It was shown that they can affect significantly the final assessment of the ground risk, to take them into account and to make the improvements to the existing model. And our future research also in the scope to investigate the impact on the model or that is developed for the kinetic energy evaluation, and then to take into account other phenomena connected with wind, like turbulence, wind shear, because the character of the phenomena can be a little bit different, unpredictable. The place can be unpredictable, so it can make impact into the final decision making also significantly. So thank you for your attention, and your questions are welcomed.
The final questions for the final presenter. So no questions.
Okay, anyway, thank you very much for your attention.
I see that my camera unfortunately doesn't work in some reason. Meet cannot use camera, I don't know why. Okay, so my camera doesn't work. And let's see. Right. So, yeah, it doesn't work. I'm sorry. Well, first of all, thank you very much for all your hard work. I know that research could take many, many years, sometimes many years, like 2, 3, half a year, it's for sure. And it's usually the different industries have a different cycle of, or the number of the articles that they could potentially publish, the researcher could potentially publish. For instance, for in history and art, it's a maximum one article, 1.5 year, and it's an article that usually takes 40 pages. In the industry like medical, it is article about the average 10 pages. In economy, it could be even 2, 3 pages. It's a very different. As you can see, the ranges are really different. They also the number of people who involve in the scientific research could be also different. Depends on the field. In the cybersecurity in general, exist many subjects. So from the mathematical point of view and calculation till the, as I said, management of cybersecurity and the leadership style. However, we're all working in on the one goal to make us more secure, more stable, resilient. And from my side, I want to say thank you to all of you. And I encourage you to continue your research in different areas, and especially to extend your research in other countries. And if possible, to make it profitable, if I may say in this way. So my best regards to all of you. Keep safe, positive, work, hardworking, innovative. This is my message from you. And I wish I can see you next time, next year, and I could read your publications in many magazines. Semen?
Yes, I also would like to thank everyone. It was really good workshop, a lot of new information, a lot of results. So I wish you all the best, to be safe and to develop your science science technologies and science direction. So thank you very much.
Yeah, bravo. Yep, we are disconnecting then.
Thank you for all reports. Tomorrow we will start as the first section at 9:30 morning. And please attend the plenary section tomorrow. Thank you for your reports today.
Thank you.
Thank you for organization. Okay, goodbye.